Alrighty, squirrels. Last one for, well, our content in order to prepare for the AP exam. So, we have a special type of pendulum called a second pendulum. It's one in which the hanging mass swings through equilibrium every second. So, what that means is, if here's our pendulum secured to the ceiling, it swings back and forth, back and forth. It's this equilibrium position here. It will take 1 second to do this, and then 1 second to do this. If we add the two together, the period of the second pendulum is actually 2 seconds. So our first question says, we'll determine the length of it. We'll use the period of a pendulum equation right off the equation sheet, 2 pi times root of L over G, and your goal is to solve for L. So 2 equals 2 pi root L over 9.81. So I will do 2 divided by 2 pi. Then I will square that and multiply by 9.81. And I got a length of 0.994 meters. So just shy of 1 meter exact. Next it says it takes it to a planet X, where planet X has a mass twice that of Earth and a radius of 3 times. So we don't need to do gravitation. What I'm going to do really quick is pause the video and I'll restart it telling you what exactly the G value is. So the G value is 8.72 meters per second squared. And now that means it's less than that of Earth, so it's going to move slower on Earth, have a longer period. We set this up on planet X at 12 p.m. and we let it run for 24 hours. And the question is, well, what does the clock read? In order to do that, we need to know what the period is on planet X. The length stayed 0.994, and G instead of 9.81 is 8.72. So 0.994 divided by 8.72. Put that whole bundle of stuff under square root, then multiply it by 2 pi. The period is now 2.12 seconds. Well, in 24 hours, you can do a dimensional analysis, or you can take my word for it. It's 86,400 seconds. Now, what that means is our clock is going to complete a total of 86400 divided by 2.12, or 40,754 cycles. Now, coming back to how the second pendulum is defined, one cycle ticks the clock 2 seconds. So, well, how much will this tick the clock then? 40,754 divided or multiplied by 2 is we'll get 81,508 ticks on the second hand, each tick being 1 second. Okay, so how many hours is that? 81506 ticks divided by 3600. That tells me that my clock has gone 22.64 hours. So at the very minimum, the 22nd hour of the day is 10 in the PM. Now I have a 0.64 hour. A 0.64 hour, if I take that and I multiply it by 60 to figure out, well, how many minutes is it? It's 38.5 minutes, or approximately 39 minutes. So my clock would say between 10:38 p.m. and 10:39 p.m.